Hi everyone,
Hi everyone.
welcome back to our YouTube video, Becoming a ROS Developer. Sorry, our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo and today we have one of our students that has taken a course, ROS Navigation in 5 days, in which he has to, in order to obtain a certificate, he has to present his real robot project, a project for the course in which he uses an actual real robot to perform autonomous navigation. Hello, Harsh, how are you?
I'm really good. Yeah.
Great, great. So, we're really excited to see your project. So, whenever you want, you can start sharing your screen and just go ahead and telling us what your project is about, please.
Okay. Are you able to see my screen? I guess
Yes,
uh,
share your screen, please. There we go. We see your screen
yes.
now.
Okay. So basically, I will start with explaining like what I have done. I have, if you can see over here, I have made many packages, and yeah. So I will be starting with the mapping one first. So do you want me to do the mapping, since I have already performed the mapping? So, or I can just simply show like how it is working in ROS.
No, you can just serve them. If you have it already, don't create a new map.
Oh, okay. So I will then go for the path planning one, and after that, I will go into the navigation.
Great.
Hmm.
I think you control C your main process.
You mean this one?
Oh no, never mind.
Yeah.
And
It's
please
just my
tell us
first
what you're
service.
doing and what we're seeing.
Okay. So, firstly, if you can see, like I have the packager for localization and I have the package for mapping.
Right.
So basically, like day before yesterday, I went into the real robot and I tried moving it around in order to generate the actual map. Earlier, I was working when I developed this code, I was working with the simulation,
Mm-hmm.
but now I try to localize the actual map environment so that I can get all the map peripheries and all the obstacle location and all that data.
Yeah.
So I have that in map. If you see over here in my screen, I have like two maps. The environment map, that is there without any number. That one is from the simulation, and environment two map.
That's
If
from
you
the
can
real
see
map.
this one,
Nice.
is with the real robot. And yeah, so this one are the I also made like three uh, launch nodes,
Uh-huh.
basically a map loader, map server, and GSLAM. I run GSLAM, I run the map saver launch, and this saves my file like over here.
Oh, nice.
Sorry. So I just have to change, like if I want to make a new map, I just
You
change
just
this
do that.
number. And yeah, and I made a map loader. I'm not using this directly, but I use this launch node. I'm including it in the
Yeah,
localization.
nice.
So I have, yeah, so like if you see over here, this is
Nice.
included over here. So I don't have to always load the map every time.
Yes, and I saw that you
So
launched something that launched the AMCL. and
Yeah.
and then the path
So
planning.
yeah, so this localization is further included into my path planning, if you see.
Mm-hmm.
So once I run the path planning, my MCL also gets loaded.
Great.
So I don't know if it is a standard practice, but I
No, I
thought
think
like
this is
if I
great.
can
I
do
think
that,
this is good.
yeah,
That way you can
yeah. So
debug and everything.
yeah, exactly. So it's more sort of a modular code that I thought like I should obtain. And for like everything, I also like not only like in the path planning, but I made param files for all the packages
Great.
as much as I can, so that like in future, if I want to just change, I just have don't have to change the entire launch code. I
Yeah,
just have to change the parameters.
that's very good.
So
That's a very good practice there.
so that's what I thought of doing. So what I would start with is I would start a tally op. And after tally op, I will just configure the AMCL and then I will start my navigation if you are okay with that.
Yes, but why do you need the teleop?
It's just that when I this AMCL, if you can see the point cloud is not actually noting the real location
Yeah,
as of now. Now it
yeah, I
is.
can see that.
So I have to firstly run the teleop, and I have tried using the one joystick,
The joystick,
digital joystick that you give. I was not able to like control it
that's
properly.
fine.
So, but my hand is very good on
But
teleop.
my question is,
Yeah,
you can just set it. So if you click on that window, the one, the
which one?
one, click there.
Yeah,
So we see where the robot is with respect
yeah.
to the map. So in
Uh,
Arvis, you can directly use the estimate, and that way we don't need to. Well, once we start path planning, you don't really need to do the tally up. I mean, just to save you time, but whatever you want. See, and then once we
I have
start
noticed, yeah,
once we start path
uh,
planning, the
mhm,
and the obviously the first goal will be a little bit uh, not that good, but it'll auto localize. But here, let me just show you how you can use the joystick. Just pull it to
okay,
one side and leave it within the circle, right? So just grab that, just leave it there, and you see it's already localizing. Then I
okay,
noticed that the best way to localize, you have to leave it pressed, is to rotate one way and then the other. So what I do is just like rotate a little bit and then rotate the other way. And there you go. We have a bit of a problem here because the map is really symmetric. So, uh, but this looks all right. At least now we know that your localization works and it's converging.
yeah, yeah. That is done. You want me to firstly like let it localize itself, or should I just send the 2D nav
I
nodes?
think, I think, I mean, depending, it's up to you. Like, do you think that's localized correctly?
It's little bit off.
Maybe,
Like,
I mean, have you launched the path planning
what?
and everything?
Yeah,
You
this
can
is
try
my
with a
path
goal.
planning only.
You can try
Yeah,
sending a
this
goal,
is my.
easy goal.
I will also add the map for my
That's a good idea, yes.
yeah, planners. I also have made a service server, so that you can send the
Some locations, right?
yeah, exactly. So like I have made for the simulation, I made three locations. I don't know if they will directly work on this one. I might have to set them up. So let me show you the most map.
Nice. There we
If
can
you
see
can
the cost
see,
map.
Yeah, so I made a voxel layer on the top. Like I researched a lot, and I saw like even on the actual Turtlebot, so they were using voxel layer. So I thought of using the same code. I didn't do very thorough research, because of which I know there are few errors which even I am not able to correct yet. But I guess that will take a lot of calibration in terms of the param file.
Okay.
Like for example, if I send a 2D node, if you can see, I just I'm able to send the go, and it looks for that okay. So
So I think it's actually not localized, right? Do you see?
it's not properly localized. Yes.
So it's actually looking up in this picture next to those two obstacles. So it obviously converged to the wrong position. And
Yeah. So I
to
have to like do it again. I
you could
think
do
I have
there's
to
a
do the
multiple ways,
localization.
but I doubt that just by doing the teleup it would unconverge from that location and then converge to the right one. Um, and
Mhm.
but I want you to understand why this is, why it's thinking it's a different spot. It's because it's a really symmetrical map. If we had a lot of distinctive features, it would
Mhm.
it wouldn't have this big of a problem. So yes, obviously, if you send the locations, I don't think they'll work right now. So just set the 2D pose estimate where the robot actually is.
Mhm.
I think that's the
So
goal.
like yeah. Yesterday when I did it, like the map was really in place. I don't know what
Yes, that's
actually
what I'm
happened
trying
right now.
to explain to you, that it's not correctly localized. You see where
Yeah,
the map is? Right now it's telling you it's at the top right corner. But you
yeah,
can see in the video, if you match
yes,
the stream
yeah.
on the right, it's actually at the bottom right corner. So what you
Mm.
need to do is relocalize it.
If you
Obviously,
want,
you
can
have
I
to tell it,
get do a pose estimate?
there you go, yes. And then make sure it's facing the right way. Right now it's not facing that way.
Mm,
Obviously
mm,
it's moving because it's trying to reach the pose, but if you can see it's like face, I mean, you need to, there you go. And like maybe, well, right now it's received the goal again, so we have to somehow
mm,
cancel this goal that it's trying to arrive to because it keeps getting localized incorrectly. You don't need to kill Arvis, I don't think. Maybe you do. I don't know.
I really wish my robot doesn't go and hit anything here.
So look, it is definitely facing towards the obstacles.
Yeah.
So it's on the left side where though you see those two little obstacles and it's facing them. So let's put it there.
So where exactly?
I mean, you tell me. So the
So
robot
what I can do?
is facing the obstacles and
Yeah,
it's on the left side. So right now in your map, you're telling it that it's on the right side and it's not. It's
yeah,
on the left and it's
yeah,
facing the obstacles,
yeah,
like in between them.
yeah. So I can like put it over
Like
here.
right there, exactly. Yeah, yeah,
Exactly.
yeah.
But I want to also like shift it a little bit back so that it doesn't hit my.
Does
let's
not
try.
matter, but whatever you want. Great. Now we're
Yeah.
telling it,
The,
it's obviously
right.
got confused because, the particle cloud also gets extended. So now we can try and move it around. Looks
Yeah,
like the
but the
joystick
joystick,
is disconnected, so you'll
the,
need to use the teleop. You see, and now it's getting localized in the correct spot. That's what I was trying to uh,
no,
put across. So now when you
no,
send a goal, it'll make more sense than what you were sending earlier.
yes. So it's a little bit off.
But it none. But this is a thousand times better than before. So just go ahead
Yeah.
and send a goal to like a
Okay. So
corner or
let me
something.
suggest the teleop first. There is a- Yeah. So let's say
Right
like
there.
I
Yeah.
give yeah, go over here. And
Might be because you're too close from the obstacle.
with the
So yeah, move away from the obstacle. For this, I recommend adding everything that you need, including the cost maps, the footprint, because my guess here is that your footprint for navigation is actually colliding with that obstacle inflation
oh,
radius.
okay. Okay. So like let's since that is done, we'll try. Yeah,
You see?
that was the real. Yeah. Let's have to switch off the teleop otherwise. Now it goes there.
Awesome. It moves really nicely. That's nice. Do you can you show us now like your service server that you told us about?
You want me to run the service server address?
Well, now we know that your navigation works, which is
Yeah,
great.
yeah. I can pull a service server. So I made my entire service server in C++. It's called
So can you tell me why the robot is rotating?
it's uh it's basically I guess it's because the problem is the tolerance of the position because of which it is like trying to go to that location but it is not settling there. So
Yes,
it's trying to like
exactly.
actually figure out. So I have to work around with the parameters, I guess.
Yes, definitely.
Yeah, because sometimes this works and sometimes it doesn't work. So
It
I,
probably works when you send it to a very open space like this one.
yeah,
So
yeah,
I'm guessing you're going to have even more problems in tight spaces. So what I recommend doing right now is adding your global cost map so you can see the
mm,
inflation radius. And also there's like if you do by topic, it's easier, but whatever.
like running the global maps wide open. So,
That looks. Is this the local cost map or global cost map?
This is my global cost map. You want a local cost map?
It's just strange. Can you change the
Yeah, that's
color
right.
to black and white? Usually you put the
This one or just want this one?
this. Okay, but
Yeah,
there's definitely something strange there
yeah, yeah. Because yesterday it was fine. Like when I was doing it, I don't know.
because you should be able to clearly see the inflation radius around the obstacles, which will tell you a lot about why it's not reaching, right? Instead of having to guess, that's one option. And then the other thing I recommend is if you add by topic,
Mm-hmm.
if you do it, so hit add,
So add by topic.
like
I
for the
didn't get
topics,
it.
like add a new element
Okay.
and then hit by topic on the second tab on top. You'll find one that's like a polygon or something. If you scroll down, it's like it will say like footprint or something like that, and it's type polygon. Here, there's one in the local cost map, yeah, and then one in the global. So try this one first. No, the other one. Drop down menu of
So
like
like
hit on the arrow of the
uh,
yeah, but the other one, the local cost map. Yeah, and
mhm.
add that.
I'm gonna use that
Did it
one.
appear?
No, not really.
It should. It's around the robot. So if you deactivate like the particle cloud and everything, you will probably see it. And well, that's an issue right there as well.
Mm-hmm.
You know what this is? This footprint?
Yeah, the footprint is anything that is around the robot so that it can actually like confirm its own location,
Exactly.
like a radius,
And we
or it
can't
can be
confirm here what's going on. Like we can't really see it. So
mhm,
I can't tell if it's a giant footprint, like the size of twice the size of it, or if it's
mhm,
tiny and it will make a crash against an obstacle. So that's another
mhm.
thing to look at when you're trying to have a well-tuned navigation system. That and the cost maps.
Because I remember like sorry,
Oh,
um,
we ran out of we ran out of
yeah,
time for the robot. So
but like I set the radius for this, which is like 0.5. But yes, I don't know why the footprint is
yeah, but
not
we need to be able to
there.
see it, you know. But
Yeah.
that's fine. Here, since we ran out of time, why don't you show us this last part? It's in around 10 minutes or so. In your simulation, you won't be like you lost
Yeah,
the
I
real
know.
robot.
I know. I can change a little bit of my code.
Yeah, nice. So there we can see this. Nice.
Not in my way. Yes, that would be enough. Yeah, that would be enough.
So then this is the same setup except in the simulation, correct?
Uh, the map is also way much better, but yeah,
Nice.
that's just
You can see why it's easier for it to localize here, right? You know, you have more features. You have one near the corner, so that's why I did it quicker.
so that is the, if you can see, like it is actually localized properly as per the direction, given
Yes.
that it is pointing toward the person which is over here. So yeah, it is pointing to that obstacle only. And yeah, so talking about like, should I start with just using my client or like my servers?
Uh huh. Let's see it.
Then uh,
So then you're going to give it a couple locations with a service server, and then it should go to
yes,
those locations.
yeah. So like if you see in my service server which I have prepared, so if I
Yes.
go to my navigation
Maybe in the
over here.
spot recorder. Okay.
Yeah, I saved. I had I made a spot recorder as well. Like it is also a service client, but like it just doesn't do anything. It just when the robot
Assigns a
goes to a
label.
particular yeah, you
I
tell
see.
it what is the label, and it saves all those labels. So basically,
I
it
understand.
was these are the all the labels, and
Hmm.
if you go over here, so if I zoom this. Cancel this one. So previously, I saved all these points.
Ah, I see.
Yeah, but in this, the problem is like the one with the label one, it is from the actual robot, and the two and three are from the simulation. So I guess I would be better
Let's
off
do
if
only
I
two or
just,
three because one won't make sense.
yeah,
Because the map frame will be published elsewhere, so it won't go there.
hold on, hold on.
You can do list first
Yeah, I have
to make sure.
because I have, yeah, sorry, it's reach label. Yeah. So let's say two. And once I do that, I really hope it works. Oh, sorry, I have to switch off my Turtlebot.
There we go.
So if we can see in the simulation as well, in the gazebo, the robot is moving. It's avoiding all the um, obstacles. Um, and then it is going forward.
And how do you know which point it is? Again, if you add everything in Arvis, everything will be just so much clearer. Because you can add the goal, but you don't need to do it right now. But just
Okay.
for your information.
Okay. Okay.
So is that spot
Yeah.
two?
Yeah. That was the spot two, and I also have the spot three. So if I go here, I do.
Which I'm assuming spot two was the pedestrian crossing.
I just.
Looking at the map.
I didn't set it that way. I just take a random locations.
Oh, you did random locations. All right.
But now it is going into the recovery behavior, and from there onwards, I guess it will. Yeah. Initially, yes, I took the actual locations only, but I really believe like later on, I just, in order to test all those things, I just randomized it. And I forgot to like actually give it the right locations. So this you see is your point three. So even if like you go over here, you can see that it will be showing the goal might have reached. And that
That's
this,
awesome.
yeah, so like it's just planning something.
So it's saying it's not arriving, and can you tell me why in this specific scenario? Why
No, I
it
really
could be
believe it
that
is
it's
the
not
main
reaching it?
tolerance. Yeah, it is the tolerance that I have set for the point. So if I can like increase the tolerance, it will start saying, okay, the point has been reached. I really believe it is that.
Right. Yes, I think so too because it's right in between two obstacles right there. Then you should see the. Um, it's probably why. But that's a great project. Congratulations, Harsh. I think we're going to wrap up here. Would you mind
Mm,
stop sharing your screen?
no, for sure.
All
Mm,
right. So we're back. So congratulations, Harsh.
mm.
It's
Thank you.
it looks like you've tinkled with it enough, but let me give you a couple of things
Mm,
to improve. And
mhm,
the first one is you need to be able to visualize. And what I
mhm,
saw in your Arvis config is that
mhm,
you don't have everything that you need. So you're basically
mhm,
debugging blindly. Uh,
mhm,
so we're just assuming that that's why the goal wasn't able to be reached earlier, but we
yeah,
don't know for sure, right? There could be a million other things. So that's why
yeah,
it's very important to know what everything is what every element is doing. So
mm,
at least always when you have your navigation, do your global cost map with the inflation radius. This will tell you the places where
mm,
the robot will not be able to reach. Then
mhm,
your local cost map in a different color.
mhm,
This will tell you dynamic obstacles and things of that nature. Then
mhm.
you should add your path. The path banner generates a path and it draws
Yes,
it really nicely in Arvis. And we didn't
uh,
know where it was going in your
yeah,
demo.
actually, like when I was doing the course, I had the path planner. It's just I didn't
Yeah,
add it. Then
but then not having it causes you to not have a tuned and well enough the navigation system that is
yeah,
just a cascading effect. And that's why it only reached one goal in your simulation, and we were having trouble in the real robot to
mhm,
to and it
mhm,
was rotating, it wasn't reaching anything. So you
mhm,
can solve that 10 times faster if you have those things. And
mhm,
I would also add the local path because the local path will change with respect to the global path, and that gives you tools to understand better what the move
mhm,
base is doing. Um, and I know the project might seem a little bit arbitrary in a couple of ways, But I recommend, instead of doing random locations like you said you were doing, to
Mhm.
make the project have a sense for
Mhm.
you. For example, call one, instead of 123, call it pedestrian crossing. Put a charging station. You know, a little bit of extra description
Yeah.
will give you two things. Will give you a faster way of debugging and you know a general sense to your project, and then more ideas to, let's say you have a robot and you wanted to go to a charging location or things like that. You can
Mhm.
extrapolate from that. Um,
Mhm.
but other than that, the things that I really liked about your project is first the structure that you did. I really
Mhm.
liked that you went by steps and you had four packages and you could launch from the bottom up, right? So you could launch just the mapping or the mapping and the localization
Yeah.
or the three things. This is very
Mhm.
important for when the things, you know, when you see an error,
Yeah.
you'll be able to like discard, okay, it's not
Yeah.
path binding, you know, so I can move on to the next one. I really
Mhm.
think that is one of the key
Mhm.
ways of maintaining like your sanity in ROS because it will
Yeah.
explode, and I
Yeah.
think that's a very well done thing. And overall, your understanding of what was going wrong, like immediately identify like, hey, no, this is because of this is because of that. So that just shows that you spent time trying to learn, and that's at the end of the day, this is what we're trying to do here in these presentations is to showcase that you actually learned something in our courses. So for that, I want to congratulate you, Harsh.
Thank you.
And yeah, for everyone else that is watching, you can do what Harsh did here for adding an autonomous navigation to a robot. You just need to go ahead and take the ROS navigation course in 5 days and just start your ROS learning here like Harsh did. So that's it for us, you guys. We'll see you next time for our next presentation, and we'll see you later. Bye-bye. Bye, Harsh.
Bye.
Okay, Harsh, we're done.